Hello students, today let us take an example of the iterative method to solve the non-linear equations. Now the question which I have taken here is that find the smallest positive root of the equation x cubed minus 5x plus 1 equal to 0 using iteration method. Okay, now here we have to find the smallest positive root. Let first of all, like we did in all other methods also, we will name this polynomial, and so I have written let f of x equal to x cubed minus 5x plus 1 equal to 0. After this, I'll find out the search interval like we did in the other methods also, bisection method, regular falsy method, Newton-Raphson method. To find the interval, we put x equal to 0 in fx so that f of 0 is equal to 1. It is again greater than 0. Then we put x equal to 1, 2. We can also put x equal to 0.5, then 1, then 1.5 and 2. Now here I am putting x equal to 1, then f of 1 is equal to minus 3. It is less than 0. Now we will stop here. Why? Because we have got two values of x for which the value of the function is positive and negative. Right? So in the conclusion we can write that a root lies in the interval 0 to 1. Now what we have to do in the iterative method or the iteration method is that here we have to use the recursive formula which I have written on the top. Xk plus 1 is equal to phi xk. It means what? That the value of x at k plus 1th iteration, or we can also say that the k plus 1th approximation to the root is equal to phi of xk, right? Where xk is the kth approximation to the root, and the value of k will vary from 0 to 1, 2, 3 and so on, as much it is required. So here now we have done this. Now the problem is to find what is phi. What is phi here? Now phi is that function that we write the given polynomial in the form x equal to phi of x. As I have done here, let us rewrite x cube minus 5x plus 1 equal to 0 as x cube equal to 5x minus 1, then x equal to 5x minus 1 raised to the power 1 upon 3. Now it is the form x equal to phi of x. Whatever is on the right hand side, it is the function phi of x. Right? So that's why in the conclusion I have written it implies phi of x is equal to 5x minus 1 raised to the power 1 upon 3. After this, we try to find out phi dash at x. That is the first order derivative at this point. This will be equal to 1 upon 3 into 5x minus 1 raised to the power minus 2 upon 3 into 5. This can be again written as 5 upon 3 multiplied by 5x minus 1 raised to the power 2 upon 3. Then what we do here? We find the value of the mod of phi dash of x for the midpoint of the interval under consideration. Now here the interval is 0 to 1. It is the open interval, right? It is the open interval from 0 to 1. So its midpoint will be 0.5. So I try to find out that whether the value of the mod of phi dash of x is greater than 1 or less than 1 for 0.5. When I did this, then I found out that the value of mod of phi dash of x is greater than 1 for x equal to 0.5. So I have written this conclusion that phi dash x is greater than 1 for interval 0 to 1. Again, some other student doesn't separate x in that form. Everyone has different mind setup. He can separate like this also. x cube minus 5x plus 1 equal to 0 can be written as x equal to 1 upon 5 into x cube plus 1 also. So that here on the right hand side we are having 1 upon 5 of x cube plus 1. That is here 5x. And I told you that whatever is there on the right hand side, it is your function phi of x. So if I separate like this, then phi of x is equal to 1 upon 5 of x cube plus 1. Again, I follow the same procedure which I did before. Here also I find out phi dash x is equal to what? 3x square upon 5. Then mod of phi dash x equal to this. And now here mod of phi dash of x will be less than 1 for x equal to 0.5. Okay. So if we take phi x equal to 1 upon 5x cube plus 1, then the iterations will converge to the root. Now what is this? It is the part of the procedure to use the iteration method. है ना? If mod of phi dash of x is less than 1, then our whole process will converge to the actual root. Otherwise, it may not converge. ठीक है, तो ये कंडीशन हमें चेक करनी होती है. जो भी फाई इस कंडीशन को सेटिस्फाई करते हैं उन्हें हम एक्सेप्ट करेंगे, अदरवाइज वी विल रिजेक्ट दोज फाई ऑफ एक्स. So ultimately what is our value of phi? It will be 1 upon phi of x cube plus 1. We write down x equal to 1 upon 5 of x cube plus 1. Now we will start finding the approximations to the actual root. I told you in the beginning that the recursive formula which we use is xk plus 1 is equal to phi of xk. I have already discussed it. Now here we will put k equal to 0. When we put k equal to 0, then we will get x1 is equal to 1 upon 5 of x naught cube plus 1. Now what is x naught here? X naught will be the midpoint of the interval which you found just at the top. You know? So this will be equal to 1 upon 5 of 0.5 cube plus 1, again 0.225. Again we will use the same formula, but here we will take k equal to 1. If we put k equal to 1 in the above formula, then we get x2 is equal to phi of x1. So x2 will be equal to phi of x1. Now phi of x1 will be equal to 1 upon 5 of x1 raised to the power 3 plus 1. Its value will be 0.2023. Similarly, we will keep on proceeding till we get the results of desired accuracy. Now here x3 is equal to 0.2016. x4 is also equal to 0.2016. So now we see that the values of the approximations have started repeating up to 4 decimal places. So we stop here, and x equal to 0.2016 is the required smallest positive root. Okay.